Hi everybody. Today we're looking at some more things you can do with vectors, and in particular we're going to look at the dot product of two vectors and the angle between two vectors. Now you see in the previous videos we can add vectors, we can multiply vectors by a fixed number like 3 times vector v or -2 times vector v, but what we haven't talked about is multiplying vectors by each other. There are two ways to do this. One way is called the dot product. The other way is called the cross product. We're just going to look at the dot product today. So let's suppose you've got two vectors. We'll call vector v has an x component a and a y component b. And suppose vector u has an x component we'll call c and a y component we'll call d. Then the dot product, u dot v or v dot u, order doesn't matter, is to multiply the two x pieces together, a times c, plus multiply the two y components together, b times d. Order of operations, you multiply those first, then you add, and that's the dot product. That's all there is to it. So as an example, suppose I've got a vector j, and j is -5, -9. So j is a vector that goes 5 to the left and 9 down. And k is a vector 6, 4. So k goes 6 to the right and 4 up. If I want to find the dot product, j dot k, then I take 5 times -5 times 6, plus I take -9 times 4. -5 times 6 is -30. -9 times 4 is -36. And so j dot k is -66. Let's do one more of these dot products. Suppose I've got a vector w, and vector w is -2, 6. So vector w is going 2 to the left and 6 up. And we've got a vector q, and vector q is 6, 2. So vector q is going 6 to the right and 2 up. If I want to find w dot q, again I take x component times x component, so -2 times 6, plus y component times y component, 6 times 2. -2 times 6 gives me -12, plus 6 times 2 gives me 12. So w dot q, -12 plus 12, is 0. The dot product is 0. And by the way, whenever a dot product is 0, we call this orthogonal. O-R-T-H-O-G-O-N-A-L, orthogonal. And I'm going to show you what that means in just a couple of seconds. But before we can talk about that, we need to talk about the second part of this video, the angle between two vectors. So first of all, we've got this formula for dot product, and you already know from previous videos that you want to find the magnitude of a vector. You just use the Pythagorean theorem. You take the x component and square it, plus the y component and square it, and take the square root of the sum. Well, if we want to find the angle between two vectors, there's a formula. Cosine of the angle between the two vectors is, u dot v over the magnitude of u multiplied by the magnitude of v. Now that's kind of a complicated formula, so let's get down into it. So going back to our earlier example, we have a vector J is -5, -9, and we have a vector K is 6, 4. And we already found out a little while ago that J dot K is -66. So if I want to find out what the angle is, I'm also going to need the magnitudes. So magnitude of J is the square root of -5 squared plus -9 squared. So the magnitude of J, let's see, -5 squared is 25, -9 squared is 81. 25 plus 81 is 106. So I have the square root of 106. I want to find the magnitude of K. So that's going to be the square root of 6 squared plus 4 squared. 6 squared is 36, 4 squared is 16. 36 plus 16 is 52. So the magnitude of K is the square root of 52. So I know the magnitude of J, I know the magnitude of K, I know the dot product. I'm going to put it all together here. Here we go. The cosine of our angle between the two vectors is the dot product goes on top over the magnitude of one of the vectors times the magnitude of the other vector. Now, what I really want to do here is I want to find out what that angle is. That's what I'm really curious about. So how am I going to do that? Well, I got to get rid of the cosine. And how do we get rid of cosine? That's right, we use cosine inverse. So I'm now going to take the cosine inverse of cosine theta equals the cosine inverse of this side of the equation, -66 over square root 106 times square root 52. And now it's going to be time for a little calculator work. I can't really do that in my head. All right, so going to my calculator, always, I start by checking my mode. Am I in degree mode? Because I want to get this answer in degrees. I'm in degree mode, that's good. So, cosine inverse of the fraction. The top is -66. The bottom is the square root of 106 multiplied by the square root of 52. And I get 152.7 degrees. So I just got that the angle right here, because cosine inverse and cosine cancel out, equals, and over here I got 152.7 degrees. 152.7 degrees, or I would probably round that off to 153 degrees. Now, even that can be a little hard to wrap your head around without a picture. So let's wrap this question up by drawing a picture of the situation. Here's the x-axis, the y-axis. Here's the x-axis. And we had vector J, which went 5 to the left and 9 down. So there is vector J. We had vector K, which went 6 to the right and 4 up. And we're saying that this angle right here between them is 153 degrees roughly. So that's what we just found. Okay, now let's take a look at that pair the other pair we had, the orthogonal pair. So our orthogonal pair, you'll recall we had vector W, and vector W was -2, 6. And I'll draw the picture first this time. -2, 6, we're going 2 to the left, and 1, 2, 3, 4, 5, 6 up. Gives us like so. Here is vector W. And then we had vector Q, which was 6, 2. So we're going 1, 2, 3, 4, 5, 6 to the right, and a 2 up. And you know, if you take a careful look at that angle, I'll bet you can tell why we call that orthogonal already. But let's go ahead and go through the math anyway. The angle is the cosine of, the arc cosine of the dot product, which is 0, over the magnitude of W times the magnitude of Q. Now, in this case, I really don't care what these two are, because I've got 0 divided by whatever this is, and 0 divided by whatever this is 0. So what I've got here is that my angle is the arc cosine of 0. And I happen to know right off the top of my head that the arc cosine of 0 is 90 degrees, pi over 2. So what do we know about that angle? What do we know about orthogonal? Orthogonal means perpendicular. So we now have a new technique in our toolbox. We can multiply two vectors using this tool called the dot product, and we know a special rule. We know that if the dot product works out to be 0, then no matter what else is going on, the angle between the two vectors is going to be 90 degrees, pi over 2.